Happy Tuesday morning and welcome back. So it is one more day of using the law of sines. So yesterday I mentioned that you could use this with an angle side angle triangle and an angle angle side triangle. There's actually one more case that we can use, and that's the angle side side. Ooh. So remember back to geometry when we were proving triangles were congruent. So back to 8th grade, back to freshman year, back to sophomore year, back to whenever you took geometry, there were different ways that you could prove triangle congruence. We've got angle side angle, we have angle angle side, you have side side side, and side angle side. It's all about the information that is given to you that you can make a connection between two triangles. So law of sines will solve angle side angle. Law of sines will solve angle angle side. If you try it out, think about an example with those two. If you have three sides, or two sides and an included angle, think about how that might look with the law of sines. Side, 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 you'd always have two missing pieces. Side, angle, side, two sides and an included angle, that'd be A, C, and angle B. You'd always have two missing pieces in the ratio. There is one more case. Side, side, angle, or the infamous angle, side, side. Now, going back to geometry, you could not use it, not because teachers said it's a bad word, but instead, there's a mathematical reason, not just because they didn't want to be looking at that on their paper all the time. Sometimes this works, sometimes this doesn't work. But let's forget about that. So, from yesterday, we've got the law of sines, and hopefully that's going well. We've got the constant ratio between a side length and the sine of the opposite angle. So, here's an example. We've got, now, two sides, a side-side angle, and one angle. So two sides and an angle. Putting things in, we've got 20.5 degrees. We've got a side length of 12. We've got a side length of 31. If we plug this into our law of sines, we now have 12 over sine of 20.5 degrees equals, well, now I know the opposite side. I need to find the angle. That's going to be sine of B. Straightforward cross multiplication. We've got sine of B equals 31 sine 20.5 over 12. Oh, we know how to do that. Simple inverse. Now, here's the point. You try this out. Find B. Go through that. Find C. And then find little c. Take a moment. Here's the point. Pause the video. Somebody's playing this up on a projector screen. Pause the video here. No, seriously. Pause the video. Try this out on your own. Take a couple minutes. And welcome back. Hopefully you had paused that. Actually, finally, here's my answer. So I've gone through, done all the work out myself. Angle B comes up to, let's just check if we got it right. I've got 115.22 degrees. I've got angle C is 44.28 degrees. And side C, I've got 23.9. Who got it right? Who agrees with me? Who wants to check my work? I can't actually see you, so you can put your hands down now. I actually have to find my other paper wherever I had some stuff. But does it work? So you came up with something a little bit different. You may have come up with something a little bit different. Sorry about that. Lost the paper. Cat got in the room. Took my stuff. You may have come up with, where am I at? Did anybody have as an answer angle B as 64.78 degrees? As angle C, 94.72 degrees. And side C, 34.15, not degrees, just a side length. Well, in that case, who's right? Let's check it out and verify. My numbers. If we plug all this into the formula, we should have 12 over sine of 20.5. We have 31 over sine of 115.22. We have 23.9 over 44. Sine of 44.28 degrees. Well, if we plug this into the calculator and check, we should have a constant ratio all the way through. So 12 divided by sine 20.5, I come up with a ratio of 34.27. We do 31 divided by sine of 115.22. 34.27. And lastly, 23.9 divided by sine of 44.8. All right, there's some rounding error in there. 34.27. Everything works out. Let's check your numbers. You had 12 over sine of 20.5 degrees. We had 31 over sine of your angle, 64.78. And your angle, what'd you see? 34.15 over sine of 94.72. If we check your values, well, this is going to be the same thing, 34.27. This now, we've got a different angle. That is going to change something. Divided by sine of 64.78. It's the same. 34.27. 34.15 divided by sine of 94.72. 34.27. So who's right? Turns out there's actually two different solutions here. If we look at the geometry behind this, we started off, we had angle A was 20.5 degrees. We had side A was 12 units. Now, we could draw the triangle like that, or we could draw the triangle like this, where, think about this being like a pivot, where it could swing back and forth, and this arm could be over here, or this arm could be over here. We have no way of knowing because the angle's fixed, this side length is fixed, and this side length here, B, was also fixed. There's two different locations that we could find. Now, in doing the inverse to solve for B, you find the one angle in quadrant 1. I found the angle in quadrant 2. Goes right back to when we were solving equations. So, here's how we're going to do this. When we have a side-side angle triangle, we could have two solutions at different times. So we're going to try to find two solutions at each step of the way. Same numbers. I'm going to go through, identify kind of the steps, how we think about this. So I'm going to start off, draw a triangle. We've got A, B, C. We've got 20.5 degrees. We've got 31 units. We've got 12 units. We're going to go through and solve just the same as we did before. We've got 12 over sine of 20.5. 31 over sine of B. So we've got sine of B is 31 sine of 20.5 over 12. And we're going to take the inverse. Careful with your parentheses. We've got 64.78 degrees. Now, here's where it could be the supplement, because this is our angle in quadrant 1, or it could be the angle in quadrant 2. So I'm going to take that and subtract and find what could our angle be. So B is either 64.78 degrees or 115.22 degrees. We find that second possible angle by taking the supplement, subtracting that value. What that's doing is either B is here at 64.78 degrees, or B is actually over here, and there's our triangle, where it's going to be an obtuse angle. It has the same sine value because it could be an acute angle in quadrant 1 or the obtuse angle in quadrant 2. They have the exact same sine values. From here, we find the two values. We're going to split this up into two triangles. So B could be 64.78 degrees, or B could be 115.22 degrees. It's 180 degrees in a triangle, so if we subtract, find angle C, we've got 180, subtract 20.5 for A, subtract 64.78 for B. One possible outcome for C is 94.72 degrees. Or triangle 2, we've got 180, we subtract 20.5 for A, we subtract 115.22, so 180 minus A minus B equals C. C gets us our 44.28 degrees. 180 degrees total in triangle. Now, because C could be the full angle if B is acute, C could be the portion of the angle if B is obtuse. There are then two different C values. C for the full triangle, triangle 1, C for the small triangle, triangle 2. We've got to go through, use the law of sines, two more cases. So triangle 1, we've got 12 over sine of 20.5, going back to A over sine A. The given information is side C over sine of 94.72. One possibility for sine. And we do the same for the second possibility. Second angle. Plug it in. $34.15 or $23.92. Two different outcomes. Both are correct. Both are necessary. It can always work that way. Let's try another one. So, starting off, we've got side-side angle. We've got 42 degrees, a side length of 22, side length of 12. First thing we're going to find is angle B. So we have 22 over sine of 42 degrees. We've got 12 over sine of B. Sine of B. We've got 12 sine 42 over 22. B is going to be arc sine of that. So B we've got 12 sine 42 divided by 22 gives us 21.41 degrees. Now what we saw from the last is B could be there, or B could be on the inside, or B is going to become 180 minus 21.41 degrees. That's the inverse that's given to us in quadrant 1, or we've got to find the supplement, the angle that it could be in quadrant 2. I've got 158.59 degrees. So we're going to set up our two triangles. We've got triangle 1, triangle 2. Now, A in this case, the given information, that never changes. So we've got B, the first possibility, 21.4 degrees, or triangle 2, B is 158.6 degrees. We'll find angle C, 180 degrees in a triangle. We've got 180 subtract angle A, 42 degrees subtract angle B, 21.4. We get angle C is 116.6 degrees. Or in quadrant 2, triangle 2, excuse me, we got 180 subtract 42 angle A, subtract the second possibility for B, 158.6, and you get C equal, 158 and 42 is already more than 180. You can't have that as a triangle if you've got two angles that are already more than 180. There's only one triangle. So what I'm trying to say here is when you have a side-side angle triangle, we'll find one. That's the one that's going to be given to you in a calculator. The second possible outcome, find the supplement. If it works, you've got two triangles. Otherwise, the numbers will cue you in and show you it doesn't work as a possible triangle, because you can't have an angle measure negative 20.6. If we go through, find the last missing side. We're going to have 22 sine 116.6 divided by sine of 42. We'll get side C, 29.4. One triangle. One more example. So, final possibility, side-side angle. We've got A, B, C, we've got 85 degrees, side length of 15, and we've got a side length of 25. Let's go through, set up, find angle B. We've got 15 over sine of 85 equals 25 over sine of B. Gives us sine B is 25 sine 85 over 15. Sine of B, plug that in the calculator,